In this video, we will do some short examples involving conditional probability. So the first example says that if the probability of B occurring is 0.6 and the probability of A intersect B is 0.45, what is the probability of A given that B occurs? Alrighty, so before I jump to using the formula for this, I want to draw a Venn diagram to visualize a little bit better what's going on here. So I'll draw a circle for A and a circle for B, all within a rectangle for our universe, which I can denote as S for our sample space of all possible outcomes. So if we think about our formula for this conditional probability of A given B, the condition here is that we are given that B has to occur. So we have to be within this circle for B, which means our sample space is going to be limited to this. So the denominator of this fraction is going to be the probability that B occurs. That is the universe we are limiting ourselves to. Okay, so if we plug in for what that is, we know it's 0.6. So now let's think about the numerator. The numerator, well, to have a success, if we're given that we're in that circle B, we're after the probability that A occurs given that you're within that B circle. So you have a success if you are in this region, this intersection region, which has a probability of 0.45. And that is what's going to go in the numerator, the probability of A intersect B. So this is our formula here for conditional probability. And now if I plug in for the numerator, it's 0.45. And if I evaluate this, we end up getting 0.75. And that's our answer. So I definitely could have just jumped straight to the formula and plugged in for both the top and the bottom and gotten my answer. But I think it's helpful to see what's going on with the Venn diagram to really visualize these conditional probabilities. All right, let's look at one other example in this video. So a word problem this time. In a town, 50% of residents own a bicycle and 30% own a car. 20% of those who own a bicycle also own a car. What is the probability that a randomly selected person owns a bike given that they own a car? All right, so let's start by labeling some events here. So the two events I see are something about owning a bike and something about owning a car. So maybe I'll let B, let's put in green actually, let's let B owns a bike, and let's let CB owns a car. So let's think about the probabilities that we're given and how I would write those like are we given P of B, or are we given some conditional probability of something given something? Let me just erase those. But let's think about what we're given and what it is that we're trying to find. So the question tells me that 50% of residents own a bicycle. That means the probability that someone owns a bicycle when selected at random is 0.5. It also tells me the percentage that owns a car. So the probability of being in C is 0.3. That corresponds to that 30%. And then there's 20%. Let's see what it says. 20% of those who own a bicycle also own a car. What that's saying is the probability given that someone owns a bicycle, so given that someone owns a bicycle, that they happen to own a car, so maybe it's better if I say the probability that someone owns a car, given that they own a bicycle, is 0.2. So that one was a little bit more tricky, that sentence. It's actually a conditional probability. The condition is that these 20% own a bicycle. Well, yeah, the condition is that they own a bicycle already, and of those people who own a bicycle, 20% happen to own a car. So the last sentence tells me what it is that I'm going to find. And that one's a little bit easier because it uses the phrase given that already. So I want to find the probability that a randomly selected person owns a bike given that they own a car. So probability of B given that C occurs. So now that I have that set up, I want to give you the opportunity to try this. Pause the video for 2 minutes to try this on your own. 4, 3, 2, 1. Pause the video and try this for 2 minutes. That may not be enough time to finish the question, but hopefully to get started and think about what the key ideas may be. Alrighty, so hopefully you've paused the video and tried this for 2 minutes. Let's talk about it. So let's try to just dive into what it is that we're trying to find and see what happens. So for this probability, if I use my formula, I'll get the probability of B intersects C on the top over the condition is C has to happen, so that's the one that goes on the bottom, probability of C. And I know probability of C is 0.3, but I don't know the numerator. So we have a question mark for that numerator. So let's try to use what it is that we're given, and maybe that'll help me figure out the numerator. So specifically, let's focus on this conditional probability. So if I use the formula on this conditional probability, I'll get probability of C given B equals the probability of C intersected with B over the probability that B occurs. And I know that this needs to be 0.2. So if I plug in for what I know, let's see, we get probability of C intersected with B over, and the denominator is 0.5 equals 0.2. And now I can multiply both sides by 0.5 to get the probability of C intersected with B equals 0.2 times 0.5. And if I multiply these, we get 0.1. So now we have the probability of C intersected with B is 0.1, but that's the same thing as the probability of B intersected with C, because B intersected with C is the same thing as C intersected with B. So I could write a 0.1 here, and if I simplify this, this becomes 1/3, and that is my answer. Maybe let's draw an arrow going here. But yeah, 1/3 is my answer. So in terms of our goals for this section, we have done a few examples using the formula for conditional probability to do a few examples. In the next video, we'll talk about what it means for two events to be independent.